Thanks for joining me on Fascinating Frontiers, episode 135. Today is July 18th, 2026. Some fascinating developments to cover today. A private Indian rocket just reached orbit on its first try, while a NASA probe wakes up billions of miles out. Vikram-1 lifted off on its inaugural flight July 18th and reached orbit successfully. The launch marks the first time a commercial Indian rocket has achieved orbital insertion. Skyroot Aerospace developed the vehicle as India's initial private orbital class launcher, with former ISRO engineers on the team. The success opens the path for additional commercial missions from the country, including future payload deployments. The vehicle completed its first flight without prior orbital attempts. Skyroot now holds both a launch license and demonstrated hardware that can be iterated for future missions. Next steps include payload integration for follow-on flights and potential scaling of the design to larger variants. While one new launcher joins the orbital club, another established deep space mission is stirring back to life after a long sleep. The New Horizons spacecraft ended nearly a year of hibernation at a distance of nearly 6 billion miles from Earth. It is currently positioned in the outer solar system beyond Pluto's orbit. Mission controllers will use the wake period for new observations of the outer solar system, including distant Kuiper Belt objects. The spacecraft continues its extended mission with updated instruments after the long dormancy. As New Horizons resumes work in the outer darkness, closer to home, another comet is putting on a visible show. Comet 10P Tempel approaches perihelion in early August after traveling inward from the outer solar system. Earth is passing through the plane of the comet's orbit, producing visible changes in the tail orientation. The comet now displays a knife-edge tail feature as it nears the sun, with dust and gas structures becoming more pronounced. Observers can track these shifts through the coming weeks using ground-based telescopes. If you shrank the solar system so the sun sat at one end of a football field, a typical comet nucleus would be smaller than a grain of sand at the opposite goal line. That tiny body spends most of its time in the distant Oort cloud or Kuiper Belt until a gravitational nudge sends it inward. As it crosses roughly 5 AU from the sun, sunlight begins to warm its surface ices, releasing gas and dust that form two distinct tails. One tail is pushed almost straight back by radiation pressure, while the other curves under the influence of the solar wind. At peak activity near perihelion, the comet can shed thousands of tons of material per day, yet the nucleus itself may be only a few kilometers across. The exact balance between sublimation rate, dust grain size, and magnetic draping that sculpts the observed tail structures remains only partly understood. While new worlds are being spotted from the ground, two long-running missions at Jupiter continue to map the giant planet and its moons. The world is the faintest alien planet yet photographed from Earth using current ground-based facilities. Direct imaging required advanced techniques, including adaptive optics, to separate the planet's light from its host star. The detection demonstrates improving capability to observe dim companions at large separations from their stars. Follow-up observations are planned to characterize the object further through spectroscopy. Juno remains active at Jupiter, collecting data on the planet and its moons through ongoing orbits. Europa Clipper is scheduled to reach the system in 2030 for focused study of the icy moon Europa. Both missions target the solar system's largest planet and its satellite system with complementary instruments. The combined effort supports ongoing investigation of Jupiter's environment, including magnetic fields and atmospheric dynamics. In contrast to steady progress at Jupiter, Russia's planned reusable rocket keeps slipping. 6 years after its announcement, the reusable Amur rocket continues to slip year for year according to project timelines. The vehicle was positioned as Russia's answer to the Falcon 9, with plans for first-stage reuse. Development setbacks have kept the project from advancing to hardware testing or flight attempts. Observers note the timeline has stretched consistently since the initial reveal without visible progress towards static fires or integrated vehicle tests. On a more positive private industry note, a U.S. company just received approval for an unusual orbital reflector test. Reflect Orbital received approval for the initial Ear-Endil satellite under the new license. The constellation aims to demonstrate space-based reflectors capable of redirecting sunlight. Astronomical groups have raised concerns about increased sky brightness affecting observations. The company plans to proceed with the first launch under the granted license while addressing community feedback. The partnership between ISRO and SCTIMST will examine human physiological responses to spaceflight, including cardiovascular changes. Work focuses on medical and biological aspects of long-duration missions beyond low Earth orbit. The collaboration draws on ISRO's flight experience and SCTIMST's clinical expertise in cardiology and neurology. Initial studies target cardiovascular and other health factors relevant to astronauts during extended stays. The Apollo lunar lander placed astronauts on the Moon during the program's flights between 1969 and 1972. The feat remains unmatched in scale by any other space program in terms of crewed landings. The article reviews the engineering and operational challenges overcome during those missions, including descent propulsion and guidance systems. It positions the landings as a benchmark for human spaceflight that later programs continue to reference. Development delays led to termination of the planned lunar lander effort after years of work. The spacecraft had been intended to deliver cargo to the Moon under a NASA contract. NASA and Draper Laboratory jointly decided to cancel the project following missed milestones. Resources will shift to other elements of the lunar architecture, including alternative lander providers. The Sweet 15 experiment subjected a 15-foot wing to loads beyond design limits at NASA's Armstrong Flight Research Center. Researchers recorded structural behavior under extreme conditions, including bending and torsion forces. The thin, braced configuration showed promise for future aircraft efficiency through reduced weight. Data will inform scaling decisions for larger flight articles in potential supersonic or subsonic applications. The 570-megapixel camera captured the Corona Australis molecular cloud in high-resolution detail. The region ranks among the closest star-forming areas to Earth at roughly 430 light-years. The new image reveals intricate dust structures resembling brushstrokes across the field. Astronomers will use the data to study early stellar formation processes within the cloud's dense cores. Images taken between May 2nd and May 15th show Mars increasing in apparent size from a small crescent to a larger disk. The spacecraft used the planet for a gravity assist maneuver to adjust its trajectory toward the asteroid belt. The sequence documents the approach geometry during the flyby with multiple frames from the onboard imager. Psyche continues toward its main asteroid target after the encounter. The orbiter recorded wave-like features with a metallic appearance in a previously lower-resolution region. The dunes sit in a mid-latitude area where wind patterns interact with surface materials. Scientists are examining composition and formation mechanisms behind the patterns using infrared and visible data. Additional orbital passes will help refine surface models and identify mineral content. The observatories measured the magnetic field around pulsar PSR J1101-6101 for the first time using combined X-ray observations. X-ray data in multiple bands reveal field structure within the nebula surrounding the rapidly spinning neutron star. The combined image shows how the pulsar's emission interacts with surrounding material through synchrotron processes. Further analysis will constrain particle acceleration models in the nebula. New missions and fresh data keep the frontier moving every week. Keep an eye on the first orbital reflector launch as the company moves forward with initial hardware under the new approval. That's Fascinating Frontiers for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for exploring with me, and I'll see you next time. And if you'd rather watch than listen, find us on YouTube at Neura Network. Links in the show notes. One more thing, if you liked today's episode, our sister show OmniView is worth a spot in your feed, a balanced daily world news briefing that takes every side seriously. It's one of the Nira Network's daily briefings, all free at niranetwork.com. New to the network? niranetwork.com/start-here picks the right daily briefing for you in about 2 minutes. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.